All right, guys, here we go. Last short week for a while, but then hey, we got spring break in about 5 weeks, so we're getting closer. Hey, one of the things I want to let you guys know is that when we're working with these, I want you guys to use Desmos.com to graph them. It makes it easier when you can see the graph. So I would use Desmos, or if you have a graphing calculator, you know how to use it. I would use it to graph these things. We're going to talk about what they look like, the end behavior. It's pretty straightforward right now. Next week we'll get into it a little deeper. But there's like 5 things we're going to talk about, and the fact that that doesn't have an underline is bugging me. So what you would do, what we're going to talk about is the degree, the leading coefficient, the end behavior, the possible zeros, and the actual zeros, and we're going to do it for 2 different types, okay guys? And so we'll kind of work our way through these here in the next 5 minutes or so. So before I get started, if you want to, go ahead and plug this into Desmos, and then as I start on this one, I would plug this one into Desmos. And you can use X in Desmos too. It doesn't matter. So you can graph those, and you should get the same numbers I do. All right, so one of the things that you have to do when you're dealing with these is they have to be arranged in degree order. So the degree is just the exponent here. So if we look at this, 8 is the largest degree, so that's got to go first. So negative 4x to the 8th. And then 3x plus 3x to the 4th power plus 6x to the 3rd plus 2x. So one of the rules is you have to kind of rearrange these things. You don't have to, but it's easier to utilize that. That pen's dead, and I made it. It's easier to look at it because we need the leading coefficient and the leading degree. These two go together. So when we look at these things and we're looking at that, that's the leading coefficient. So this is the leading coefficient. The degree is the power of the leading coefficient. So this one would be x to the 8th. The leading coefficient is the number and its sign in front of it. So the leading coefficient is negative 4. So there's a couple of pieces of information here that I want you guys to understand. When it's an even number, when the degree is even, then they're either the ends are going to be up or down, both of them, okay? And the leading coefficient, I'm going to put LC here, the leading coefficient, when they're both pointing up, is positive, and when they're both pointing down is negative. So this one is a degree of 8, and leading coefficient is negative, so both of them are pointing down. That's what this tells us, okay? So that brings us to end behavior. End behavior talks about what happens as x approaches negative infinity and what happens as x approaches positive infinity. In other words, if this graph keeps going that way, what happens to the graph on the y-axis? So for this one, it would go towards, it would approach positive infinity. Both of these ends would go, right? So what we would say is, as x approaches, that's what that means, negative infinity, going to the left, then y is going to approach positive infinity. And then the other one, as x approaches positive infinity, sorry, this is negative infinity. What am I talking about? This is negative infinity. As x approaches positive infinity, y goes to negative infinity. It's like, it's not 8, guys, it's a sideways. Y goes to negative infinity. Okay? So as x goes all the way to the left, y is going to go straight down. On the right side, as x goes to the right, y is going to go down. Which makes sense because both sides are pointed down because it's negative and it's even. The number of possible zeros, in other words, the number of possible x-intercepts, so we can write that into, these are also known as x-intercepts, or solutions, is always equal to the degree. So the possible number of zeros for this one is 8. Possible. Doesn't mean they always have them. Now this last piece, how many zeros does this actually have? It only has 2. It has an x-intercept here and an x-intercept there. So this only has 2 zeros. Actual zeros 2. One of the zeros is x equals 0, and the other one, x equals 1.224. That's why it's easier to use the graph for these. Okay? So again, let's recap real quick. The degree and the coefficient tell you if it's going to be up or down. The ends are going to be up or they're going to be down. If it's an even one, both of them are going to be up, both of them are going to be down. That tells us what our end behavior is going to be like. In other words, if I go all the way to the left, what's that side going to do? If I go all the way to the right, what's that side going to do? The number of possible zeros is equal to 8. The number of actual zeros you got to get from the graph. And that's kind of the main idea of what we're talking about this week. So let's go ahead and look at this one here. So our degree is 3, which is odd. It's not even. Notice how 8 was even. So this was even. So like it would be like 2, 4, 6, 8, 10. So now this one is odd. So we're talking about 1, 3, 5, 7, 9, those types, right? So the degree, because this is already in order, is 3. So that tells us a couple of things about this one. Also, it's negative. So it's negative, so that means the leading coefficient, I'm just going to call it LC, the leading coefficient is equal to -1, because there's a negative out there. So what does that tell us about this? So let's talk about odds real quick. Odds, odd degrees are either like this, one pointed down to the left and one pointed up to the right, and that's if the LC is positive, and the other way is one's pointed up to the left and the other one's down to the right, and that is if the LC is negative. So if the leading coefficient is negative, it points up to the left and down to the right. If it's positive, it points down to the left and up to the right. So degrees always have these ends that look like that. So what does that tell us about our end behavior? Remember, put these in Desmos. So our end behavior, guys. So if this is our end behavior, let's look at the graph to talk about the end behavior. If I'm going this way towards infinity, negative infinity, right? If I keep going to the left, what does this one do? This one goes towards positive infinity. So this is x equals negative infinity, and this is x equals positive infinity. So let's write our statement. As x approaches, keeps walking that way, negative infinity, y approaches positive infinity. Let's do the right side. I'll do it in a different color. Let's do it in orange. So as x approaches positive infinity, y is going to approach, keeps going down, 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 negative infinity. It's not -8, it's negative infinity. So as x approaches positive infinity, going this way, y is going to keep going down, so y is going to approach negative infinity. So that makes sense, because if it's a leading coefficient that's odd, degree, and a negative, we're going to point down, which means we're going to go down towards negative infinity, and we're going to go up towards positive infinity. Okay? So let's talk about possible zeros. Possible zeros. Let's look at possible zeros here. We look at the degree. Possible zeros should be 3. That's the total number of possible zeros, actual zeros. Actual zeros are going to be, let's look at it. 1, 2, 3, because they're x-intercepts. So we have actual zeros, we have 3 of them, and one of them is x equal to negative 3.214. X is equal to negative 0.461, and x is equal to 0.675. Okay? So that's how we kind of deal with end behaviors, leading coefficients, and all those things. So we're just kind of listing these things out, guys, for the ones that you see. Remember, they have to be in decreasing order. So I'm going to erase this left half, and I'm going to talk about this one in a different way now. So let's go ahead and erase this part here. All right. This will help you with number 8 on worksheet 4. Number 8 on worksheet 4. Okay, so let's assume this equation here is for a business profit, let's say. Just giving you a real basic idea. So we put it in Desmos here. So we've got this graph that looks like this. I drew it a little differently here, guys. So, oops, goes down, goes up, something like that. And then we have 0.675. We have, here we go. We have negative 0.461, and we have, I can't remember what that one is. That one is something. Where is it? Negative 3.214. So we have these basic ideas here. We also have a couple of different things here. So if this is about the business profit, and this is x equals 0, right? And this is, let's say, the number of units produced. Can we have negative units produced? Because if this is x equals 0, am I going to produce, if I own a business, let's say the units is shoes, am I going to produce negative 1 shoes? No. So this side of the graph is what we call irrelevant. It makes no mathematical sense because the number of units is to the right that we want. We want to be able to produce 1 shoe, 2 shoe, 3 shoe, 4 shoe, 5 shoe, whatever we need, right? Okay? So this left part of the graph doesn't really matter. And if we're talking about profit, we're talking about profit here. So if we're talking about profit, don't you want to make money? You want to make money, not lose money. So we don't want anything that's negative. So this part of the graph is irrelevant. So this part here is the only part of the graph we want. And right up here is 1.155, 1.079. Okay? And again, this is just an example. So basically, what we're saying is that I'm going to get a maximum, this is my max profit. This is my max profit here because it's the highest point on the graph. Remember, we're business, so we want the most possible, so that's my max profit. This right here, this x value, is the number of units that give me the max profit. Okay? That's the number of units that give me the max profit. And then the last thing is the boundaries. In other words, I want to produce more than 0, but I want to produce less than 0.65 because I want to stay in between these two. So I would want to produce between 0 and 0.675 units because that is where profit is positive. Remember, profit is the y-axis. So we want everything above the y-axis that's on the right of 0. So we want it in between these two right here. So we want it between 0 and 0.675. All right, guys, so we've got a relationship for number 8. We've also, don't forget, we got degree, leading coefficient, end behavior, possible zeros, actual zeros. You guys can find this on, I'll have to get you the page number. I'll put it there, but it's 4.3, I believe. I don't know where my book went. Let me look for it real quick so you guys have it. Here it is. Page 208, guys. Page 208 in the book is where a lot of this stuff is. So it starts on page 208. All right? All right, guys. Good luck, and we'll talk to you soon.